Hey mathematicians, it's Justin again. Today we've been asked to help Mia and her cousin Ren get their very own lemonade stand up and running. Check out the progress they've made so far. Wow, the stand looks amazing. So where are the ingredients for lemonade? And the cups? Pitchers? Straws? Okay, we should figure out how much of everything we'll need because a trip to the store is definitely in order. By the end of today's lesson, you'll be able to figure out if one number is a multiple of another, list all the factors of a number, and explain the difference between multiples and factors. Have your guided notes ready? And let's get this lemonade stand fully stocked and ready for business. All right, we have a list of all the items we need, so what better place to start than the lemons? We need exactly 45 of them. In this store, lemons come in bags of 5 or bags of 8. Which type do you think we should buy so we have exactly 45 lemons? Let's check the bags of 5 first. One bag would be 5 lemons, 2 bags would be 10 lemons, then 15, 20, 25, 30, 35, 40, and 45. That's 9 bags with 5 lemons in each for exactly 45 lemons. Notice how the number of lemons keeps increasing by 5 each time? That's because we're multiplying 5 by 1, 2, 3, and so on. These total amounts are called multiples. Multiples are the products you get when you multiply a whole number by other whole numbers. For example, 45 is a multiple of 5 because 5 times 9 equals 45. Multiples never end because we can always keep multiplying by another number. Remember, there are also bags of lemons with 8 in each bag. Can we get exactly 45 lemons by buying bags of 8? Pause here to show your thinking in your guided notes. Skip counting can be a very helpful strategy to figure out if one number is a multiple of another. Let's skip count by 8 to figure out if 45 is a multiple. 8, 16, 24, 32, 40, 48. Ooh, 45 isn't in that list. What does that mean? It means 45 is not a multiple of 8 because there's no whole number we can multiply 8 by to get exactly 45. 8 times 5 equals 40, and 8 times 6 equals 48. Since 45 falls in between those products, we can confidently say that 45 is not a multiple of 8. And we should buy the bags of 5 lemons instead, since 45 is a multiple of 5. All right, we've got the lemons. Next up is the sugar. We need exactly 72 cups of sugar to sweeten our lemonade, and it comes in boxes that hold either 4 cups or 9 cups. Which size should we buy to get exactly 72 cups of sugar? You might want to try skip counting or using your multiplication facts. Pause here to show your thinking in your guided notes. Let's start with the boxes of 4 cups. You might have listed out all the multiples of 4 to get to 72, and that's a great way to do it. But since we know that 4 times 12 equals 48, how can we use that to figure out if 72 is a multiple of 4? We can start at 48 and skip count by 4s from there. 52, 56, 60, 64, 68, 72. And that works. 72 is a multiple of 4 because 4 times 18 equals 72. And the boxes with 9 cups? We could skip count like this, or maybe you remembered 9 times 8 equals 72. That means 72 is also a multiple of 9. I think I'd rather buy 8 boxes instead of 18. That'll be way easier to carry. Ren and Mia are grabbing a few more items before we check out, so let's meet back at the lemonade stand to organize our supplies. All right, now that we have everything we need, we can finish getting the stand ready. Mia and Ren bought 36 cups at the store. How can we arrange them into equal stacks on the table? We could start with one super tall stack of 36 cups, just like how 1 times 36 equals 36. Can we arrange the cups into 2 equal stacks? Yeah, 36 is an even number, so we can divide the cups evenly into 2 stacks. It's not one of our common math facts, but we can figure it out by skip counting. 2, 4, 6, and so on until we reach 36. That would be 18 cups in each stack, like how 2 times 18 equals 36. Let's use a T-chart to keep track of these amounts. On one side, we'll record the number of stacks, and on the other, we'll record how many cups would be in each stack. So 1 stack of 36 cups and 2 stacks of 18 cups. How else can we arrange these 36 cups into equal groups? Pause here to record at least 2 more ways in your guided notes and add them to your T-chart. You might have found that we can also arrange the cups into 3 equal stacks. Each stack would have 12 cups because 3 times 12 equals 36. Or maybe you discovered 4 stacks of 9 cups works because 4 times 9 equals 36. And we could even have 6 stacks of 6 cups. The numbers we're multiplying together here are called factors. These factor pairs, like 4 and 9 or 3 and 12, help us figure out all the ways we can group our cups into equal stacks. We could also list 9 times 4 and 12 times 3, but do we need to? Nope, they're still the same factors, just in reverse. Once we've found all the factors, we can arrange them from least to greatest to keep track of all the pairs. Mia and Ren also bought 15 pitchers. How could we group them into equal stacks? Pause here to find all the factor pairs that equal 15 and then arrange them in order from least to greatest. We could start with 1 stack of 15 pitchers, or 1 times 15. Would 2 stacks work? No, 15 is an odd number, so it can't be divided evenly into 2 stacks. What about 3 stacks? Yes, each stack would have 5 pitchers because 3 times 5 equals 15. And that's it. 1, 3, 5, and 15 are all the factors of 15. So how are factors different from multiples? Do multiples ever end? Nope, they go on forever. But factors, every number has a specific set of factors. Try practicing both with one last problem. List the first 5 multiples of 7 and then find all the factors of 30. Pause here to record your thinking in your guided notes. The first 5 multiples of 7 are 7, 14, 21, 28, and 35. As for factors, 1 and the number itself will always be a factor pair. It is a great place to start. So for 30, we have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Great work. So, what have we learned today, besides the fact that we're friends with some real entrepreneurs? Well, now you know that multiples are the products you get when you multiply a whole number by other whole numbers, and that multiples go on forever. You also know factors are the whole numbers that multiply together to equal another number. and every number has a specific set of factors. Be sure to complete the practice questions and extension activities that go with this lesson to practice working with multiples and factors. Remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.